All right, bro. So today we are basically, I'm leaving it open to you. It's going to be a review. This is our last session before we meet in person. So between now and the time we meet in person, obviously I want you to continue on and do your own exercises. So I want you to basically ask me questions, stuff you want to go over, and we're gonna spend today going over that.
Okay. So
And go ahead and start sharing your screen too.
one thing I got a question on um is the classes. Like I'm understanding that okay, we create a class and then we start creating the objects or elements that's basically picking up some of the characteristics of that class that we're creating. But it's some of the functions that I'm trying to just kind of understand. Like once I we start typing them out, when you kind of put it in the air, like what it is, like it kind of connects to my brain, but it doesn't like. How can I explain it? It's something that I'm not picking up on. Like, oh, okay, I know what you're talking about. Like for example, when you speak about like calling it, like you be like, hey, call this element, or call, you'd be like, call something, and I'd be like, I kind of get lost when you be like, call.
Okay. So you have your class, and then inside of your class you have your methods, right? The difference between a method and a function is the only difference is that a method is a function that's inside of a class. Okay. So here you have a stat class, and it has one, two, three, four. It has five methods. It has the init method, the push method, the pop method, the print method, and the bump method. All right. So whenever you instantiate a new class, like what you're doing on line 15, stack equals new stack. Every time you make a new object, which an object is just an instance of a class, okay? It always calls the init function, okay? Every object calls the init function. If you do not define what the init function does, then it just gives you an empty object, okay? But we want to define some data when we create a stat class. Like we want to set the array equal to an empty array, right?
Yeah,
So you override the init function by defining your own init function, which is what you're doing on line two. So instead of calling the regular init function, it's going to call your init function or method. Okay.
and that method is what self dot array.
The method is init, but what your definition of init does is it sets the array.
Got you.
So whenever I say define a new method, that's the define part is the def init self, and the definition of the actual method is the self dot array equals empty array. Okay.
Got you.
So when I tell you call the push method on the stack, like what you're doing on line 16, I'm basically saying call the push method on your stack class, which you do using the dot notation. So it would be stack dot push.
Got you.
Now, you can have multiple instances of a class. Okay. So let's say you had stack one, stack two, and stack three. Stack one equals stack, stack two equals stack, stack three equals stack. So you have 3 stack variables, okay? Each one of those has its own, like, it's its own instance of class. That's why you have to say stack equals, and then you make a new stack. Because what you're saying is, I want a new instance. So you can have 2 stacks that have 2 completely different elements in it.
Mm-hmm.
And their print method will return different results because their arrays are different.
Got you. And that'll be that stack class.
Right. Well, that stack object. You only have one stack class. That's what you
Correct.
define in line 1. But you can have multiple instances of the stack object.
Got you.
So think of the class as like the definition, like a dictionary. It's the definition of the object.
Okay, and then the objects and the elements are basically creating like the little sentences of the definition.
Correct.
Okay. Got you.
Okay. So what else you got for me?
So you see how it's like, so we'd be like, okay, let's use the pop function, right? We'd be like def pop self, and then at the bottom we got the return. I forgot what you call it that I get confused on. But what's the word that you would say to return?
The keyword. I'm confused. What word? So return is a special keyword that Python recognizes.
Correct.
So when you return something, like some functions, you want it to give a value back. Okay. Whenever you want to give a value back, you're returning it. Okay.
Correct.
So all right. So what term? I'm confused. What term are you talking about?
Let me see. I forgot the term, but sometimes it'd be certain terms. I think it's different terms that you use that kind of get me confused. But I get what you're saying with the return part, definitely. Let's see what else questions. Um, so question. Um, right here on this init function, right? On class. We basically got more objects in there or elements or variables. Correct?
Yeah. So those are variables. Those are parameters.
Or parameters.
Right.
And we're defining them right here, correct?
So, okay, we know that you always pass self in, right? Self always goes in. And then the title, author, and number of pages are parameters that we set, okay? And then we take those parameters and we set that equal to the class data. So, a class has data and it has methods. Okay, we already went over what the methods were. The data in this case would be the self dot underscore title, self dot underscore author, self dot number of pages. Okay, that's the
Correct.
data of the book class. So when we create a new book object and we pass in title, author, and number of pages, we're setting the initial uh, data of the title, author, and number of pages.
Of what it's equal to.
Correct. That's what's called
Okay.
initialization. We're giving it the values. So on line 15, you have nonfiction equals books, one life, Harry Pete, 678. You are setting the initial value of the title, the initial value of the author, and the initial value of the number of pages.
Correct. To non underscore fiction category.
So if we were to add another function to this, a method to this class called change title, and it took in a title as a parameter, we could change the self dot title equal to the new title.
Got you. And then once we add more parameters, right? And then we start making them get defined with the self dot underscore title. Do we have to put the underscore once you add more variables?
Say that question one more time.
Do you have to put the underscore once you start adding more parameters?
You don't have to do the underscore. So in other languages, there's a concept of public and private data, right? Python doesn't have that concept. So what you do instead is you put an underscore on the data that you like conceptually want to keep private.
Got you.
It's more of just like a best practice type of thing.
Okay. Okay, so right here we're doing on this is like a dictionary. So okay, we're defining the function of person. So when we're doing first equals x bracket first, right? Is that array since we're using the square brackets?
So dictionaries and arrays both use the square bracket notation.
Okay.
So remember what a dictionary is. A dictionary is a key and a value, right?
Uh huh.
So our keys are first, middle, last, age, SSN, and birth. So like for Keisha, the first key returns Keisha. The middle key returns Danny. The last key returns Parker.
Correct.
The age key returns 23. So if we look at our function person, it takes in X, and we're treating X as a dictionary. So we're grabbing the first, we're grabbing the middle by grabbing the key. So we're grabbing the value by grabbing the key.
Got you.
So on line 2, first, X first is going to return the value. So if we pass in person Keisha, first is going to equal Keisha, middle is going to equal Danny, last is going to equal Parker, age is going to equal 23. You get what I'm saying?
Yeah. So another question is, you know how sometimes when we end like a we'll end like a function and we write print. I mean not print. What is it? What's the word? What is it? Pass, I believe. That's one of the keywords. Pass.
Yeah. So I'm sorry. What about pass? So
So like right
pass
here,
is
we use the
code.
word pass after we finish the function, right?
Yeah, you don't have to. So pass is the end of the class definition. It's optional. I was just showing that to you so that if you ever see it in code, you know what it means.
Okay. All right. And that means the end of the class or the end of the
Yeah,
function.
yeah, the end of that block. You can do pass anywhere where you have a semicolon or not a semicolon, a colon.
Yeah.
You could add a pass at the end. That's just showing where it ends. So you could put pass at the end of your methods, right? So like on line 3, you could put pass at the end if you wanted to, but you don't have to because Python reads based on the indentions.
Got you. Another question, like on stacks, why don't we do any addition?
Because from line 15 to line 25, that they're all in the same scope. Okay. So no indention is like the top scope. That's like where your main functionality is going to be. And then stuff gets indented when it's like related to the scope of something. So like if you have an if statement, the code is indented inside of the if statement because that code belongs to the if statement. You only
Got you.
run that code if the if statement it runs. Otherwise, you don't run the code. And Python understands that the level of scope and who's the top owner of the code by how many indentions it has. So 0 indentions is top level. So look at line 8. Okay, you have your defined print, and then you have your colons, and then you have the indentation, right? Where print self dot array.
Correct.
The reason why print self dot array is indented is because print self dot array only belongs to the scope of the print function.
Got you.
If it weren't indented, then it would throw an error because Python would be like, well, what are you doing? What is print? What is self dot array? What is print?
Yeah, I know sometimes when we run codes, if the alignment is not correct on an indentation, it's not going to run properly.
So line 15 through line 25, that's your main code. That's the main part of the script. Everything above line 15, you were just defining your class. That wasn't your actual logic of the script.
Got you.
Hold on 1 second for me.
Go ahead.
All right, I'm back.
So like I believe on this code right here was basically, or the script was basically just having these numbers get placed in a particular order or round in a particular order.
Say it one more time.
So in this code, we basically was trying to organize. The script is basically organizing the numbers that we trying to have the range go to.
Right. Well, line 6 should be divided by should be mod 2, not mod 5. So remember what the modulus division does. It returns the remainder. So what you're doing is like fizz divided by 5 and whatever the remainder is. It should be divided by 2 because we want to check to see if it's odd. So if the remainder is 0, then it's even. And if the remainder is 1, then you know it's odd. But what was the other question? But what was the question about the code though?
Um, a question is, I think basically, I think I just gotta just look up on these terms, but like, um, so we have like the variables, fizz equals 5, flag equals true. So what is this type of setup called? Because we're not using a class, we're not using a dictionary.
What is what type of? Can you be
This
more
this
specific?
this whole script, is it just a script?
Yeah, this is
Because you
just a
know,
regular script that we're using. So this was the code that I was showing. We were going over loops.
correct, correct.
So yeah, you don't have to put in. You could write a whole script that doesn't use any classes, uses no functions. But you know that's usually not the most optimal. So when we were going through these examples, I was just showing you examples, like so we could get an understanding of loops. But in a traditional program, it wouldn't look like this. You would have your classes and your functions and all that.
Got you. So for in range, that's a while loop.
That's a for loop.
For loop. Okay, for loop. Okay, I just gotta get that implanted in my head. That for I can't think of English. That's the thing. Understand that the functionality this for has a functionality instead of just it's not just number four. So when you run this function, or yeah, when you run that function of the for loop, it's always the formula is always going to be for n for whatever variable n.
Yeah. So yeah, for whatever variable, and then you can either do in or you can pass in. Yeah, for in, and then you know whatever
Whatever
it's
variable.
right.
Okay. And then
Anything that so the term for that is what's called iterable. So anything that is iterable means you can iterate over it. So that could be a range, that can be a list, uh, it could be an array. It can be anything that you can iterate over that has multiple entries in it.
that's what you saying the I is standing for?
I'm saying you can loop over you can do a for loop over anything that is iterable. So the range part where it says range 1, 1,000,
Yeah.
like you could have replaced that with an array and it would have been went over all the elements in an array
Got you. Okay.
because both those are iterable.
Got you. Understandable. Definitely understandable. So things like keywords like even and odd, those are like keywords that Python definitely understands
No,
the
you said
definition.
even and odd.
Yeah, even and
Okay,
odd. Those are two
no,
keywords.
no. A keyword would be for, if, everything in purple.
Okay, okay.
So what even and odd, everything in white, those are just variables. So there's only a few words in Python that are keywords. There's like return, def, for, while. Basically, like I said, anything that's purple.
Okay. So like okay, we let it know that it's what's even. We let it know what's odd. So like for example, for even and odds, we basically having even equals the function of fizz is equal is even, and then we have odd equals f fizz is odd. Um, for fizz to get defined, basically that fizz percent two equals 0 is the way that just understanding that which one is which, right?
Okay. So on line 1, you define a variable fizz and you set that equal to 5.
Correct.
All right. Remember what an if statement, what goes inside of an if statement? What kind of expression?
If statement. Most likely in the if statement, you're going to be talking about the variable.
So, okay. So an if statement takes a Boolean expression. And remember, a Boolean is something that returns true or returns false,
Correct.
right? So inside on line 6, we have fizz mod 2 equals 0. Now remember what equals does. All right. So one
Correct.
equal sign, you're setting a variable. That's an assignment operator. Okay. You're assigning a variable. Okay. Does
Mm-hmm.
that make sense?
Yeah.
All right. Equals is a comparison operator. So it's comparing to see if the two things are equal. Okay.
Got you.
And if they are equal, it returns true. And if they're not equal, it returns false. Okay.
Got you.
And remember with the mod operator, the percent sign, that does the division and returns the remainder. Okay. And
Got you.
whatever the number is that you're modding, the remainder will always be 0 to n minus 1. So if you divide something by 3, the remainder can only either be 0, 1, or 2, because you wouldn't have 3 remainder 3, because that would be 2. Get it?
Yeah.
So if you do something mod 2, what are the only options for the remainder?
If you do mod 2,
So if you divide
0.
well, 0 and what else?
1.
Correct. So read line 6 like in sentence English. Read what it's saying.
If fish divides 2
Not
equals
divide, not divide. It's mod.
mod. Okay,
Yeah.
if fish mod 2 equals 0.
And what does equals mean?
True or false?
It returns true or false, but equals means does this equal this? Your does fizz mod 2 equal 0?
Got you.
True or false? All right. So on line 1, on the first go around, you set fizz equal to 5, right?
Correct.
So 5 mod 2. What will that return?
0.
No. What is 5 divided by 2?
5 divided by 2.
Yes.
You really can't divide 2 by 5.
Well, what's the remainder? If you did remainders, how many times does 2 go into 5? Whole times. How many whole times does 2 go into 5?
3 times?
No. 2 times 3 is 6.
Like 0.4.
It goes 4. It goes a whole time. It goes in there 2 times because
Yeah.
2 times 2 is 4, and that's the closest whole number you can get to 5, right?
Got you.
So what's the remainder?
1.
Correct. So 5 divided by 2 is 2 remainder 1.
Oh, okay. That's the
So
leftovers.
yeah,
Remainder is basically what's remaining left over.
yes, and the percent sign does it. So the mod
That's some
operator
weird math shit.
it returns the remainder. The
Got
regular
you.
division returns the actual division. The mod division returns the remainder.
Got you. That's why
So
you
what
say
is
0. That's why you saying it's
it's
either
either
0, 1,
0 or
3,
1?
0, 1, 2.
No, it's not 1 or 2 because when you do a mod, it's the number and is that number minus 1. So if you did mod 10, it would be 0 through 9. If you did mod 7, it'd be 0 through 6. If you did mod 3, it'd be 0 through 2. So mod 2 would be 0 through 1.
Okay, 0 through 1.
Because
We
what is
start.
the
We start.
definition?
I get the number order we starting at because 0 counts as a number.
Correct.
So the first number is going to be 0 and 1. And you
Correct.
saying if we do 10, it's going to be 0 through 9.
Correct.
Okay.
So now what is the definition of an even number?
What's the definition of the even number? If it is
It means what number, if you can divide a number by what, it's an even number.
4.
What, okay, and
Or 4 divided by 2.
what is the factors of 4?
2.
Right. So any number that's divisible by 2 is even.
Correct.
But if you divide something by 2 and it's even, what's your remainder going to be?
0.
Correct.
Okay. So divided by 2 equals 0. Print
So if
even.
the remainder is 0,
Okay, I got you. So if it's anything odd, it's not going to be equal to 0.
Yeah, if it's odd, it's going to equal to 1. Any odd number is going to be the even number remainder 1. So like so 3. 3 divided by 2 is 1 remainder 1. 5 divided by 2 is 2 remainder 1. 7 divided by 2 is 3 remainder 1. 121 is 60 remainder 1.
Got you.
You get it? You get what I'm saying?
Yeah.
All right.
Yeah.
So if fizz mod 2 equals 0, then print even. Else, print odd.
Got you.
And then after the if statement, you see line 10, line 8, and line 6 are all on the same indentation.
Correct.
Because they all have the same precedence. They all have the same scope. Do the if, do the else, and then after the if else, we want to increase fizz by 1. And then it starts the loop and then we go back to the top of the loop. Because now I is equal to 2. Because, for I in range, after everything inside of the for loop is done, it goes back to the top of the for loop until we get to 1,000.
Got you.
So this first go around, fizz equal to 5. At the end of the if else, fizz equals 6. We go back up to the top of the for loop. If fizz, the mod 2 equals 0, what's fizz now? It's not 5 anymore. Now it's 6, right?
Mm-hmm.
6 mod 2 is going to equal what?
3.
Why would it equal 3 if we just said that the only available values are 0 and 1 for mod?
Oh, 0 and 1.
So what is 6 mod 2?
It's gonna be 0.
Correct. So we're gonna print even, right?
Correct. Yeah.
Okay. Now what do? We did the if statement.
So now it's gonna be else.
No, we don't need to do the else. We only do the else if the if doesn't
match.
The if isn't true. Right. So we did the if, we skipped the else. Now what do?
We go to the for loop.
You skip the step. What's after the else?
So basically we got the variables of buzz equals 3, flag equals true. And then now we have the for loop.
No. After what are we doing after the else statement? What is
the so the else now we speaking about our other option.
After the else, what are we doing?
So we're going to print
after else, print odd. What are we doing? What is the next line?
Equals fizz plus 1.
Right. So fizz was 6. Now what is fizz?
7.
Right. Now we go back to line 4 inside of the top of the for loop. Fizz now equals 7. Correct. Now let's go over it again. What is line 6?
Line 6, so it's basically what is 7 mod 2.
Okay, what is 7 mod 2?
And 7 mod 2 is basically going to end up becoming 5, which is going to be
5. No. What? Okay. What is 7 divided by 2 with the remainder?
That's going to be 6.
No.
Because 5 goes into 7.
Where are you getting 5 from?
Oh, my bad. That's addition. My bad. We on multiplication. Basically, it's gonna be 3.
3, and what's the remainder?
1.
Okay. So.
Okay, yeah, I gotta dig deeper in this.
Yeah, we're not changing anything. We're doing the same thing over and over. Okay. So
Yeah, it's
fizz,
just my brain
so,
keeps switching back over to regular addition shit.
so
It's
fizz mod 2 equals 1. So that if statement, it returns false. So that means we're going to go to, if the if statement didn't go through, that means we go to the what?
if the instrument go through, we go to the fizz equals
No,
fizz plus one.
no. If doesn't go through, then we go to the else.
Else correct.
All right. So what are we doing?
So we basically gonna print odd.
Okay. All right. Cool. Now what's the next step?
We're going to fizz equals fizz plus one. So basically, we're about to add on top of that seven.
All right. So now what is fizz?
It's eight.
All right. Now let's do it one more time. Go back to the top of the for loop on line 4. Go down to line 6 and tell me what's going on.
So basically, it's gonna be four mod two
4,
equals zero.
8.
Me eight. Sorry.
All right. So what is 8 mod 2?
Eight mod two is four.
No, it's not. 8 divided by 2 is 4.
Correct.
But
So really, it's gonna be two.
how can it be 2 when mod 2 can only
Oh,
return?
sorry. It's sorry. It's an even. It's even. So it's gonna be zero.
Correct.
Yeah. Oh, this is a different world, man.
Hmm.
It's a
All right.
whole. It's
So think of it
similar.
like, all right. If we wanted to simulate a dice game, all right, we wanted to simulate CeeLo or craps. I'm personally a CeeLo guy myself. But anyway, so how many sides does a dice have? A standard dice.
Like both sides.
A
Five
four-sided
sides.
a four-sided die will be a pyramid.
Like five sides.
Five-sided
Six.
die wouldn't be even. Most dice have 6 sides on them.
Yeah,
That's like,
six.
yeah. So if you wanted to get if you wanted to like grab the size of a die and you know it's going to be 6 sides and you want to use modular division, what would you do?
Yeah, six sides in my division. So it'd be six to mod two or
No,
mod
you would do mod 6, but mod
mod
6 is going to return what?
zero.
0 through what?
Six.
No. Remember, it's n minus
Oh,
1.
through zero through one. I mean zero through two.
Modular division returns the number minus 1 from 0 to n minus 1. So if we do mod 6, it returns 0 through 6 minus 1.
Okay, so it goes down to negative.
Negative. No. What is 6 minus 1?
Six minus one.
Yeah,
That's gonna be five.
right. So mod 6 will return the possible values of 0, 1, 2, 3, 4, 5,
Got you.
which is 6 numbers. 0, count it on your hand. 0, 1, 2, 3,
Two,
4,
three,
5.
four, five. Correct.
So if you wanted to shift it up to get 1 through 6 instead of 0 through 5, what would you do?
So basically gonna do eight.
No. Okay. All right. If I wanted to simulate a dice roll, okay,
Yeah, you got six.
so I would do mod 6. You got that part. But mod 6 would only return 0 through 5. But since I'm
Correct.
simulating dice and we're talking about real people and stuff, we would want to show them 1 through 6 instead of 0 through 5.
Got you.
So what is the simple thing we could do to each number to make it 1 through 6 instead of 0 through 5?
We're gonna go up a number, so we're gonna do 1 through 7.
One
We're
through,
gonna add. It's gonna be 7 instead of 6.
no. 1 through
Mod 6.
6. No. You're overthinking. All right. So we already got the numbers 0 through 5. That's 6 numbers. We literally want to when we show it to the client or to the user. We just want to shift it up one number. So if I have 0, but I want to show 1, what do I do to 0? Just add 1.
So if
I got 0 through 5, but I want to show 1 through 6, I just take the value and I just add 1.
okay. So
And
yeah, that's what I'm basically saying. But so when we instead of mod 6, it's gonna be mod 7, right?
no, it's not going to be mod 7 because mod 7 will return 0 through 6.
That's what I'm saying. That's what if we wanted to get 6
We
on
don't
there.
want 0. No. Because if we did mod 7, that will return 7 elements, 0 through 6. That's 7 elements. We don't want 7 elements. We want to keep the 6 that we have.
We want 6 elements.
Yeah, we just want to modify the elements that we had. So, if the user rolled a 3 on the dice, right?
Yeah.
The computer will show it as the number 2 because we started at 0.
Correct.
So instead, to compensate, so the user knows that they got a 3, we literally add the number 1. We're not adding to the possibilities. We're just taking the value and just literally adding, doing addition. When I'm saying add, I'm not saying like add on to. I'm saying literally like add, like addition.
Add like addition. Are you saying just change it, modify? Like just modify it and change it?
Right. So okay. So you have on line 6, phys mod 2 equals 0 and return 0 and 1.
Uh-huh.
Like, let's say you wanted to say 1 and 2 instead of 0 and 1, just for whatever reason. You just add 1. Like, literally, just like add 1. So, okay. I want you to, online, I want you to copy everything inside of the if statement. So, copy the phys mod 2 equals 0. No, inside of the parentheses. Inside the parentheses.
Damn, what's making this shit so hard?
All right. Okay. Put your cursor by the 0. And okay.
My bad, I don't got a mouse pad, so
It's all good. Now, on the line above it, like put a space between the odd and the if.
So do you want me to copy this?
No, I want you to put a space between odd and if. Put a new line. Not right there. Not undo that. Between line 5 and line 6, add a new line. Now, print. Now, inside of the parentheses, paste. No. Like paste the phys mod 2.
Yeah, that's what I was asking. Are we gonna be copying this? You said no.
Yeah, I said copy everything inside of the parentheses. Yeah, I was saying don't copy the whole if line, just copy the phys.
Gotcha.
Now do get rid of the equals 0, and then do space +1. All right. Now I want you to run that program. All right. Now scroll up. All right. Right there. So you see it says 1 2 1 2 1 2
Yeah.
instead of 0 1 0 1 0 1.
Yeah.
It's because we like that's what I was saying. Just add 1. So 1 2 would be the if we were simulating dice, it would instead of being mod 2, it'd be mod 6, right? And so
Mm-hmm.
instead of being 0 through 5, we would have 1 through 6 because that's the human, like it's the same thing. I mean, as far as like the modular, like you're not changing the modular division because the modular division is returning either 0 or 1, and then you're just taking that result and adding 1.
So it says 1 2 1 2 1 2.
Instead of 0 1 0 1 0 1.
So where's it getting this 2 from? From printing from the mod. That's the mod.
Yeah. So okay, what's 2 minus 1?
1.
So every time there was an even number, it produced 1. So we're just adding 1. It's literally just adding 1. Okay.
Gotcha.
Uh, uh,
I get what you're saying.
okay.
Because it's basically saying I'm looking at the numbers now. Each odd number is a 1. Each even number is a 2.
Yeah.
Okay.
No, reverse.
Huh?
Each each even number is a 1.
No, each even is a 2.
No, because an even number, the mod division is 0. And we're taking 0 and adding 1. If it's even, I mean, if it's odd, then the modular division returns 1. 1 plus 1 is 2. Look, okay.
Are you basically saying like since we add in 1, so like for 87 it's odd?
The number above it says A7 is odd. The number above it, the 2, is showing the odd. It goes 2. Okay, scroll up all the way to the top where it first starts showing. All right,
Okay, so the top number goes to the bottom 5 is used. That's odd.
right.
So go ahead and explain it.
So 2, 5 is odd. 1, 6 is even. 2, 7 is odd. Now, get rid of that +1 in the print statement and save and run it. Scroll down. Scroll down. Scroll down. You're still on the old program. Scroll all the way down. And keep going. Keep going. Keep going. Like you got a lot. You got a lot of way to go. Like I would take the thing and scroll. There you go. All right. Now you see it says 0, 1.
Yeah. Oh.
Hold on 1 second for me.
Go ahead. That's where I'm at. We're on the same page. Oh, yeah, that's what I'm talking about.
All right. So, uh, you got any more questions?
That's mostly it.
All right. Cool. Well, I will go ahead and stop the stream, and then we can talk about our plans for the last part with the Raspberry Pi and everything. All right. Well, YouTube, I will see you all tomorrow. Have a good day.